Awesome. So now Box2D is created and can be updated each frame. Our next step is to add physics bodies to the world so that we can simulate them properly. To create a physics object, we have to jump through a few hoops. The first thing we need to do is actually create a body def object. Now, body definition object is going to be used later to actually create our body, but what we do here is that we actually set some specific properties on it. For example, whether or not it's dynamic or static. Think of static objects as the ones that will never move in your environment. Walls, trees, stone chickens, things like that. Dynamic bodies are the ones that move and can react to physics. Once you've set your properties for your body definition, you need then to call world.createBody. This will actually tell Box2D to create a physics object based on the definitions that you just passed into it. And of course, it will return a handle to this object so that you can use it too. Once your object has actually been created, the next thing you need to do is actually set the physics properties on the object. Box2D does this using what they call a fixture definition. Now, a fixture definition defines properties that allow you to set the density, friction, restitution, mass, things along these lines. Basically, how this object is going to interact with the physics of the world around it. Generally in a game, you'll have groups of objects that all resemble the same similar physical characteristics. As such, you may want to go through and actually group them into certain types of fixtures. For grits, we actually have the majority of the objects in the world use a specific type of fixture object that react to the world the same way. However, we have one type of bullet that can be launched from the bouncy bullet gun that actually uses a different fixture. As such, we allow the entity def object passed in from the user to actually have a flag defining whether or not this is a bouncy fixture object. From there, we can actually set the density and friction differently so that it hits the wall and contains its velocity moving forward. As you write your game application, it's probably worthwhile to take into account how all things should react in the environment and use different fixtures appropriately. Now, once you've defined the fixture information about how the world should react with the object, we actually need to define the shape of the object. The shape is the most critical as it defines how this object should interact with the rest of the world. Now, Box2D has support for polygons, circles, and oddly enough, boxes, right? Who'd have thunk? Now, it's worth pointing out that most physics engines support a suite of hull definitions, but give huge performance wins to simplistic hulls like spheres, circles, boxes, and cubes. Polygons are always an option, but expect to pay a performance penalty for the flexibility you're gaining. The fixture definition supports a suite of these APIs, such as the setAsBox method, which of course will define the fixture definition as a box. Once you've got all these parameters set, you call the createFixture method on side of the body definition that's been given to you, and this will effectively attach the shape and information to the body definition. From there, you're pretty much done. You've got a physics object that'll react to the world and do all the things you tell it to do, so go ahead and return it out to the calling function.